Hello students, hope you all are enjoying my videos and concepts are clear, following it properly. Now, welcome to today's class. We are going to discuss about exponential. Now, exponential powers and laws related to them. Now, in your previous classes, you have learned to start up with, will recall few important concepts like what is the volume of a cube of size 2 centimeter. Now the volume of a cube was each side is 2 centimeter will be definitely 2 centimeter into 2 centimeter into 2 centimeter. Clear? Which is 8 centimeter cube. This can also be written as 2 centimeter cube. Similarly, for square, area of square, what it is? It's side into side. Many of you may say it as side square. So, even this is also right. When we are multiplying two sides, we are mentioning it as side square. When L into B into H, that is length into breadth into H, height, where all the three are same, we are mentioning it as side cube. So, to take one more thing, like 2 power 5, what it is? It's 2 into 2 into 2 into 2 into 2. That means we are multiplying 2 5 times, which is equal to 32. So, any number which raised to the power m, where a is a number, it could be any number, like it could be an integer, it could be a rational number, it could be a normal number also, and powers could be an integer, or integer means we can cover all negative and positive integers. So, we will be discussing about how the powers are negative, what we are going to do under the law of exponent. 2 power 5 is equal to 32. It means a number raised to a power means this is called as power and 2 is the base, which we are recalling already. The concepts are taught in your previous classes. So 2 power 5, where 5 is power and 2 is the base. Now using this power and base concept, we will be discussing about powers, laws of powers and exponent. So till here I hope the concepts are clear. Now let's go for laws of power and exponent. Now we'll be starting with the first law. Okay, we are starting with laws of exponent. So first law says, if a by b is a number, here we are taking it as a rational number. Now, if it is raised to power m, this is nothing but a power m by b power m. Now, to explain this, we'll take a help of an example. Let's take it as 2 by 3 power 4. Clear? 2 by 3 power 4 means 2 by 3 into 2 by 3 into 2 by 3 into 2 by 3. That means 2 by 3 to be multiplied 4 times. Now, this is in the form of fraction. Now, fraction multiplication says all the numerators to be multiplied together and all the denominators to be multiplied together, whether they are like or unlike. This, if we come to power and exponential form, this comes as 2 power 4 and 3 power 4. This exactly the law says. The law says a by b, where a and b are two different numbers raised to the power m, is equal to a power m and b power m. Means when a number is allotted with a whole power, it is equivalent. Equally, we can divide the power to both the numbers. So this is our first law. Now, before going to second law, I would like to tell you three important concepts. The first concept is, whenever 1 is raised to the power 4, the answer is 1. 1 raised to the power 5, the answer is 1. So this concludes, even if 1 raised to the power 100 we are talking about, the answer will be 1. Clear? And the second concept is 2 power 1, or we are talking about 100 power 1. So if 1 is raised to any power, the answer is 1. If a number is raised to the power 1, the answer is 2 or 100. If you talk here, it is 2, here it is 100. And the third one is the most important one, where we say that if the base is negative, okay, the base is negative and the power is odd, answer will be negative 1. If the base is negative and power is even, in that case you will get plus 1. Why it is so? If we recall the properties of integer, when minus, see, even means it starts with 2, 4, 6, 8. So we have a pair of 2. Now 2 negatives when multiplied will give you a positive sign. Clear? So that is why even negative base with a power, even power will give you a positive answer. And when a negative base is raised to the power of odd, means you will get 2 minus and minimum is 3. If it is 1 also, the answer is negative. If you have 3 and multiplying it, again the power is going to be negative. So what are the 3 important conclusions? 1 raised to odd or even, a positive base raised to odd or even powers will result you with 1. Any number raised to the power 1 will give you the number itself. Negative base, if raised to the power odd, will give you a negative answer, and negative base raised to the power even will give you a positive answer. Now coming to the second law. The second law of power and exponent says that if a power m into a power n, then we will be adding the powers. We are observing here that the bases are same, powers are different and multiplied. Multiplication is nothing but repeated addition. So we are adding the powers here. How we are adding? Let's see. See, if it is 2 by 4, not 2 by 4, let it be 2 by, you can say 5, power 3 into 2 by 5 power 2. So what this means? 2 by 5 multiplied 3 times, and 2 by 5 again multiplied 2 times, which is nothing but multiplication of the numerators and multiplication of the denominator. This is 1, 2, 3, 4, 5. This is 2 by 5, and this is also 5 times. So this is 5. Clear? Now what is 5? 3 plus 2 is 5. So what we are saying, a power m into a power n is equals to a power m plus n. So this was the practical application. Let's go for the third law. The third law of power and exponent says when bases are same and divided, powers are different, we are subtracting this in case m is greater than n. Clear? Now we'll see how this works. Like again we will be taking an example of 2 power 5 4 divided by 2 power 5 divided by 2. If you take 2 by 5, a number, a simple number, so this means 2 by 5 into 2 by 5 into 2 by 5 into 2 by 5 upon 2 by 5 into 2 by 5. So this pair cancels, this pair cancels. You are left with 2 by 5 and 2 by 5, which is nothing but 2 power 5 by 2. So here if we say a power n is equal to a power m minus n, where m is a positive greater than n. If we consider the example for m m is less than n. So before going to that, we need to go for fourth law of power and exponent, where it's clear that fourth law says a power minus n is equal to 1 by a power n. Clear? A power minus n is equals to 1 upon a power n is your fourth law, and this is taken for granted. Now, based on this, if m is less than n, then what we will do? As we have taken the example as 2 by 5 power, let it, here 2 comes and here let it be 4. Clear? So that means 2 by 5 into 2 by 5 upon 2 by 5 into 2 by 5 into 2 by 5 into 2 by 5. Now here also 2 times it's cancelled. You are left with 1 by 2 power 5 square. Clear? That means when we are doing it and m is less than n, in that case 1 by a power n minus m, or when we subtract, the power will be negative. If it is negative, we will be taking the reciprocal of that. Reciprocal, I hope you know, you have seen in the multiplicative identity, just the reverse of a given number. So to recall it, the reciprocal of 2 is 1 by 2. The reciprocal of 2 by 5 is 5 by 2. This is the number and this is reciprocal. Clear? In short, x and 1 by x in general form if we talk about. So, let's get to the fifth law of power and exponent, where we will be seeing, with this law, we will be seeing what will happen if during division m is equal to n. Now, fifth law says a power 0 is equal to 1. Now here we will be checking when m is equals to n in the third law. How we will check? See, a power m divided by a power m. Clear? This will give you a power m minus m, and that is a power 0, which we are saying is 1. How it is? 2 by 5 power 2 divided by 2 by 5 power 2. Now 2 by 5 into 2 by 5 upon 2 by 5 into 2 by 5. Clear? We are cancelling both the numbers. What we are left with? Numerator 1, denominator 1. Final answer is 1. Clear? So, we are not only learning the laws, we are practically checking it with an example. Coming to the sixth law. Now, sixth law says, if A is allotted a power n and the whole is allotted n, then the resultant will be a m into n. How exactly it is? This is 2 by 5 power 4 whole power 2. So, as we know, m into n is equal to n into n. We can write it in both the ways. But following the BODMAS, we need to follow the BODMAS. According to that, we will be solving the inner bracket first. So when we are solving the inner bracket first, that means we are writing 2 by 5 4 times. Isn't it? Raised to the power 2. Now what we will do, this pair of, we will accept it as a pair and we will be multiplying it 2 times. Sure. So if you see clearly what we have done, we have written it 4 times and then again 1, 2, 3, 4. Here and 1, 2, 3, 4. So what does this means? 2, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Which is nothing but Clear? 2 multiplied 8 times, 5 multiplied 8 times. So, we have seen here also that a power m whole power n will be nothing but a power m into n. Let's recall it. All the 6 laws of power and exponent. The first law says a by b power m is a by b m and m. Second law says a power m into a power n is equal to a power m plus n. Third law says a power m divided by a power n is equal to a power m minus n if m is greater than n. If m is less than n, you will get a negative 1, and that is 1 by a power n minus m. The fourth law says a power 0 is equal to 1, and fifth law says that a power minus n is equal to 1 by a power n. Sixth law says a power m whole power n is equal to a power m by n. See, the laws are not allotted to a number. It is not fixed that the first law will be the first law. We are just recalling all the 6 laws at a time together. No fixed numbering is mentioned as such. These are the properties based on which we are going to solve our problems. Now, if it is a by b power minus m, so this can be written as a power minus m and b power minus m, or it can be written as taking the reciprocal as I have explained, power m. So when we are taking the reciprocal, the negative sign goes off. Clear? How does this goes off? This is minus, so 1 by a power b m. This is nothing but a power m and b power m. Now this will go up, will become b power m and a power m, which is nothing but b by a whole power m. Clear? So let's take few examples and we'll be solving them. Now the examples are, if evaluate is given. What is evaluate? Evaluate is, in the power and exponential form of the problems are given, you are supposed to exactly find the value of them. Like 2 by 3 power 4. What it is? 2 by 3 power 4 is 2 by 3 into 2 by 3 into 2 by 3 into 2 by 3. So this is 2 2s are 4, 4 2s are 8, 8 2s are 16. By 3 3s are 9, 9 3s are 27 and 81. So this will be the answer for evaluate of this. Let's take minus 5 by 2 power 4 power 2. So this is minus 5 by 2 into minus 5 by 2 will be 25 by 4. Clear? Now third example is 2 by 3 power, not 4, let it be minus 4. If it is negative, then it is 3 by 2 power 4, and that is 3 into 3 into 3 into 3 by 2 into 2 into 2 into 2 will be nothing but 81 upon 16. As in the last I have discussed, a by b power negative is allotted. That means b by a power, the same power with positive sign, and how it was already been explained. So the simple is simplification is like this. We are mentioning it in the simple form and writing. So this was how to evaluate. Now we'll consider examples for how to find the exponential form. For writing exponential form, if we given a question as 16 by 81, so we cannot apply any law. What we will be doing? We will be writing it in the simplest form, 2 into 2 into 2, and this can be written as 3 into 3 into 3 into 3 is equal to 2 by 3 power 4. Clear? Now this form is called the exponential form. Okay, if 32 by 243 is given, so what we'll do, we will be multiplying to 5 times, and this means 3 multiplied 5 times will give you 2 by 3 power 5. So isn't it so easy to write the numbers in exponential form and to write the number in, evaluate the value of that. So now we will be taking 2 more examples. So we'll see 2 more examples. 2 power 3 whole power 2 is in the form of a power m whole power n. So what was the resultant? It was am into n. So the same we will be doing here. 3 into 2 is 2 power 6, which is 2 power 6, 2 multiplied 6 times. 2 into 2 into 2 into 2 into 2 and into 2. So 2 2s are 4, 4 2s are 8, 8 2s 16, 16 2s are 32, 32 2s are 64. Yeah. Now let's take the second example where a is in the rational number form. So the same will be applied here. 4 into 2 is 8. So 2 power 6 is 64. What is this? Is 1 into 1 into 1 into 1. 1, 2, 3, 4, 5, 6, 7 and 8 upon 1, 2, 3, 4, 5, 6, 7 and 8. So 64 into 2 is 128. 128 upon 2 is 1 upon 256. Clear? So we will be ending today's session with this, and we'll be meeting soon with the second part of this video. But I would request you to kindly go through all the laws, so that when we will be rehearsing, when we will be solving the problems, the concepts, laws will be clear on your fingertip, and practical application will become very easier. With that, we will also including scientific notation as one of the important topic which is will be useful for you in your physics also. So thanks for now. We'll meet soon with the second part.